So welcome to the third episode in a series where I'm sharing tips and tricks on Arduino programming. Interestingly enough, the first video in this series has recently taken off like a rocket, so that's sort of motivated me to pump out this new episode. Generally, topics I cover on this channel are various projects that I'm working on, be it machining or electronics, or really whatever takes my fancy at a given time. However, this series is a little bit different in that it's primarily for you, the viewer. So if you do have any questions or topics you want me to cover, then please let me know in the comments. I also suggest you take a good look at episode 11 in my mini lathe series if you haven't already seen that. It's got a fairly substantial Arduino interface implementation that I made. I expect it has various features that people would want to learn about, so just let me know if there's something there that interests you. And of course, please don't forget to like or subscribe if any of my videos interest you. So this episode will continue on from the code we made in the last episode, so if you missed the prior episodes, I probably recommend you catch them first if you can. Now, the only comment that I've received so far in this video series was related to how I handled the debounce, the button up and the button down methodology that I'm using. So with that taken to heart, for this episode, I will show you some new button functions, specifically how to implement a repeat key function, how to implement a long press function, and how to detect simultaneous multi-press buttons. Does that make any sense? Or whatever. Anyway, let's get straight to it. So we're starting off with this code that we ended up with at the end of the second lesson. So we have the basic menu structure and we have the multitasking going on, right? So the multitasking doesn't really matter for this discussion. We can just put it to the side, but just know that the multitasking is running in the background, but it's not all that relevant to this discussion that we're having here today. Looking at the menu here, we can see it's up and running. And if I navigate through those, it's exactly the same as we left off. Cancel. So we're going to embed this testing somewhere in this menu, but we'll do that in a little minute. First of all, let's set up the application. So what I mean by an application, well, we can just call an application as a piece of code that's looping around and doing something, right? We'll just call that an application. So all of these menus, including the main menu here, you can see that they have a while loop here, which is basically just looping around quite long, isn't it? Down to there, right? So it's just looping back and forwards and whatever. So that's sort of what I would call an application. I'm sure some people want to be picky about it, but I'm not really worried about that. So let's just stick it down the bottom here and make the application. And then after we make the application, we will link it so that it can be accessed from that menu structure that we made. And then we'll actually add all this button type testing that we wanted to do. So I'll stick it down below this submenu 3. And as usual, I've already done a bit of work on this to save some time. So I'll just copy and paste some bits and pieces. 1, 2, here. So the name of the subroutine is page sub press test. I think that's a pretty silly name. Maybe I'll change that. Let's call it UI test buttons. How about that? Sounds good. And this loop will look pretty much the same as we do with the rest of these loops. We'll have a pacing mechanism because that's just the way I'm structuring it. It could be different if you have a different type of application, whatever, it doesn't matter. And the pacing mechanism is by using a milliseconds tracking variable. So you know when it enters the top of the loop and then it waits for a specific amount of time before continuing on. So the loop will always run at a certain pace. And then we have the main loop of the application here, from here to here, with no specific exit criteria built into the loop structure. So the exit criteria must come from somewhere else. So as we enter the loop here, we will capture the milliseconds time, and then at the bottom of the loop, before we continue on, we'll do that pacing code. And here I actually use delay, but I'm actually using my wait routine. And if you don't know what that is, then you need to go back and look at the other episode. You can use delay, is fine. It will just mean that the background tasks will not operate. So this is pacing at 25 milliseconds. And a few other things that we're going to add here to this little application is a title. So we will clear the screen and we'll put the title on just before we get into this loop. So it's not going to be within the loop, it's only going to happen once, just as a description. And I will also have a cancel option. So it's a little bit of a description about how to use what features we've implemented. So the title, the functions available in the application, and just a divider line. And then we need a way to exit out of here. So in other words, we need to go back to the prior menu and we need to know which one we're going back to. Now there are a few different ways I could have tracked which menu I came from, which one I went to, but as I know the structure, I'm just going to do it directly. So we'll put it as a part of the first sub menu, and maybe we'll change the title of that in a minute. We don't want to go back to root menu, we want to go to submenu 1. So let me just take it from here so I don't get it wrong. Submenu 1. So there we have the fundamental structure of the menu basically, and the rest of the stuff goes here. Okay, done. So we've got the basic structure of the routine done here, so let's link it into the menu structure so we can access it. This is the key branching area here in the main loop. This is where, depending on the page that has been pointed to in this current page variable, it will branch off. So obviously we need to have the branch to get to this new menu. Better call it something. So that will do. UI test buttons. We'll add it to our enum up here. So that's one of the many. So we want to branch off from submenu 1. So let's go there. So right now there's no ability to branch off. We can only cancel out of this menu as you've seen in that first episode. So what I will do is I will add the ability for this to act similar to the main menu, which means I can branch off to something. And to do that, we just need to add back in a little bits and pieces, which is obviously we need to have the accept button working to be able to move. So accept, up, down, cancel, and we need to capture the was down state for accept. Doesn't really matter where you put it here. Okay. So now that will give us an ability to sense the accept button in this submenu 1. And next up we need to have the ability to accept in this submenu 1 to go to wherever we want to go, right? And in this case, once again, I'll go from the main menu and I'll just steal this accept code. And it doesn't really matter where we put it so much. We'll put it before the cancel just because I think it looks better there. One bracket out. There we go. So in this case, for this submenu, we actually have 4 items. And this is the first item that we will actually change, and we'll call it UI buttons test. And as none of the other menu options can actually do anything, we'll just leave the case 1, which is that first item in the list. And if it was down, we'll tell it to go to, I've forgotten the name, so I'll copy and paste it. That's always the safest thing to do. UI test buttons. So that means now in that first submenu, the first item of that submenu will have this test application accessible from there. You know, this is quite descriptive here, but the main menu just says submenu 1, which means we don't know where we're going anyway, so we'll call it something else. It's a silly name. UI testing apps. So the first item will be the UI testing apps, which will obviously be submenu 1. And then within here we have this UI buttons test, and we have hopefully activated the accept button now here. So accept was down, accept button is up, it will go to there. So we know how this works. It will set the new current page value to being this, and it will return, which will return it back to the main loop here. We'll go back around, we'll have now the UI test buttons and go off to that page. And then obviously when it comes back, it'll then go back to wherever it's going. So, have I got anything wrong here? Well, let's give it a go, see how many mistakes I've made. Oh yes, I've managed to miss capturing the cancel down here. So let's add that. In fact, what I'll do is I'll capture all the button states here just because I know I'm going to use them all for this test. And we'll do that anywhere is fine. We'll do it just after the loop, I guess. And here we go. Obviously we don't have any of these. This is how it goes, guys, and I don't mind showing you this because this is actually how I typically code. Is I just keep writing and then I've forgotten a bunch of stuff and I fill in the gaps, and it's quite okay, and you should feel pretty comfortable to do that too. Nobody's perfect and nobody remembers everything, especially when I'm doing it like this as well. It's not really an ideal way to be doing it. So I think this is a little bit exaggerated in the amount of errors, but generally it goes like this. Okay, so here is the updated screen, and we have now UI testing apps in the first menu option, and we can move down through this and hopefully go into this UI testing apps, and here are all the UI testing apps, and we've only got one, which is the UI buttons test, and we'll go into there, and it just says that there's nothing we can do. We can just, the screen says it's the button, press test screen, and press cancel to exit. We press cancel, and we go back. Now, an important point about this cancel routine, and I've explained it in the prior episode, but I'll just reinforce it now, is that it only executes after the cancel button is released, and this is critical for this menu structure. You press the cancel button, and then you release, and then it goes, okay? If it executed just when I did the down, when I pressed down, it would then execute all of the other cancels in the other menus as well, and that would cause a collapse of the menu structure down to the root menu, which is not what you want. So that's why I'm doing it this way. It's waiting for both the down to be detected and then the release, and then it goes back. And that's why we see that when I go OK and then cancel and then release, it only goes back one, and cancel again and release, and it goes back to the root. Okay. Anyway, we've got the test application set up, so let's get on to actually doing something interesting. So what I want to do in this first test is I want to set up a test variable, just a number variable that we can manipulate up and down using these up and down buttons. And instead of just pressing one at a time up and down, what I'll do is I'll do a repeat key. So when you press, it will gradually increase the value over time, so you can constantly press and it'll get faster and faster. Anyway, you'll see what it means. It's a repeat key structure. I mean, if you press a key on the keyboard here, if I press X and hold it down, it gets faster and faster, right? It just keeps repeating. So that's what we're going to replicate, that type of thing. And I think it's extremely useful. I use it a lot in my mini lathe menus. So it's something that I wanted to share with you. Now, maybe different ways of doing it, but this is why I'm doing it. So sit back and let's see how it works. So first I'm going to add the description just to keep ourselves in line. So press up and down to change value, and we need a value to change, and I'll add it up the top here. So this test value is just a uint32 type, and I'm setting it 500. I think we'll manipulate it between 0 and 1000 just for the sake of it. And we will, just after this sort of entry of the main screen here, we're going to actually show the current value, which is obviously going to be 500 as it first comes in. But just to, put it on the screen there so people can see it when they come into the test menu and get some idea of what's going on. So there we actually put the test value on the screen. So it's not going to refresh the value, it's doing it outside of the loop. So it's only going to just put it on the screen for us for now. So as we manipulate it, we'll have to update it on the screen. It's going to be very rudimentary. This is not exactly the way I would display it in a real display type scenario. Because I want to accelerate the repeat, I want to know how many times the button has repeated so I can keep track and decide how fast or how long to wait between the next repeat. And then we also need to know when the last repeat was done. So we have these two variables which I'm going to create for the up-down button tracking. Just after here, test value, how many times we have repeated, and the last time the repeat occurred. So we can track when to do the next repeat, basically. Now I keep these repeat keys as a pair. So the up and down buttons here are going to operate as a pair, and so you can only go up or down. You can't go up and down. So the if structure that I'll use will be an if-else type structure. So we'll do it just below capturing the button states, and we'll manipulate the test value. So we'll have an if, we won't write the code yet, and then we'll have an else if. So basically one if will be for the up, and one if will be for the down, and then we're going to need one more routine, which is pretty much a cleanup for the repeat count situation, which I'll talk about a little bit later, but let's just add it for now. So one more else if in this chain. So you should know, if you don't know, this chain here, only one of these items will actually execute, if any of them. What I'm going to do is create a new routine called button repeat. Button repeat. And we'll make it in a minute, but for now, what I'm going to use this for is to return a logic value, a function to return a logic value if the button has been repeated. Okay, so in other words, if a certain amount of time has passed and the button is still down, then it will actually trigger this action, basically. So the button we are looking at, we have to tell it. So button down was down, so we'll hand it the button down state. We're also going to have to hand it the button last repeat milliseconds that we made earlier, and the button repeat repeat count, so the number of times we repeated. So we're going to give it the button down state for button down. We're going to give it the last time we actually did a repeat and the amount of times that we repeated. Now, in my original implementation of the mini lathe, I actually implemented this fairly messily because I didn't have a good knowledge of C. If I was writing other languages that I know, I wouldn't have done it that way, but I was just in a hurry, so I did it. So what I was doing is that after I actually got out of this condition, in other words, this condition was true, I would then manipulate these values within this section of the code. And the reason I did that is because these values are local to this subroutine. So by just passing the value, I could give the value to the button repeat subroutine, but I didn't really know how to manipulate those values from that subroutine. So in other words, the manipulation of these values had to be done within this subroutine. In this version that I'm going to teach you, I'm going to teach you a better way to do it because I bothered to go and research it. So what we'll do, instead of actually just giving the value to this subroutine, we will give the address of the value. Now, we'll tell the subroutine where the value is so that that subroutine can manipulate the value. So hopefully you have some basic idea about this, but when you actually do a function like this, you are just handing, typically in the structure, the number value, or in this case, the logic value, yes or no. So the receiving function only gets a yes, or the receiving function only gets a no, or the receiving function just gets the number value. When it gets that value, it puts it into its own variable, and it will allow you to manipulate that variable, but that variable is a different variable from these original variables. They're not connected. So the manipulation means nothing to these original variables. But in reality, we do want to manipulate these variables in that subroutine. So how we do that, instead of passing just the value, we pass a reference or an address value to the function. And obviously that function has to be expecting an address type function or a reference type function as well. If it was BASIC or some other type of language, usually you do something like a by ref, and that tells it that it would be a by reference, or a by val, which means it would be by value, and you could specify the way that you are handing that information. In C, they do have the same. If you just put it in its raw form, it will always be by value, or the value itself. If you put an ampersand before it, it will pass the address, and that means you can then get a hold of that variable in that remote routine. So in this case, we don't need to manipulate the button down state remotely. That is all handled in this routine in any case, but we do want to handle the hand over the repeat address and the repeat count so they can be manipulated in that subroutine. And we'll take a look at how that works in a couple of minutes. So in this section of the code, we're looking at down, and then in the next section of the code, we will look at up. And in this bottom section of the code, it's really a cleanup action. So what we will say is that if the button repeat count is greater than 0, in other words, a repeat has occurred, and now both buttons are up, and I'll just copy and paste. So this will mean that if the button repeat count is greater than 0 and both buttons are confirmed to be in the up state, it means that the whole process of repeating is finished and we need to do a cleanup. So I'll do this cleanup first. It's not that complicated, so I'm just going to copy and paste it in here for you. Post cleanup will look like this. And it's a very aggressive cleanup. It just forces all the buttons that was down to be no longer down. So in other words, the actions are all cleared. It will start from a 0 start for all of those down states, and we reset the repeat count to 0, which obviously means that this will no longer be valid. So there you go, that's the cleanup actions. I don't want to go into too much detail. We're just clearing those down states and we're clearing the repeat state so we can get into a clean situation. So if the down repeat state is confirmed as active, or the up case is confirmed as active, then we want to do the specific action. So let's look at one of those actions. And here it is. So let's look at the first thing that we're doing. We're doing a test. If the value is greater than 0, then we do this next action here. So the limits are being set. It can't be any less than 0. it will execute this code if the repeat is detected, but it will not manipulate value or reprint the value on the screen. So if the test value is greater than 0, then we will be able to do this test value minus equals 1, which is subtracting 1 from the test value, and then we will update on the screen the current value of the test value. Now, even though we did this cleanup here, and this is really a safety cleanup, so when it did repeat and then it released, make sure everything is clean, we are actually going to do this cleanup action also in here as well. So why do we need to do this? Well, I think the key thing is these two items here. This up and down as they're operating as a pair, we're clearing everything as a pair. If we don't clear it, then it's always going to continually be down and it's always going to continuously trying to repeat. So we need to clear it here. And we're just clearing the others as well, so we don't have multiple key triggers or anything else. So basically these up-down buttons are going to take priority and they're going to clear, and they have to be reinitiated here every time the loop comes around. And for the next section, I will just copy and paste this because it's pretty much the same. And what I'll say is if the test value is less than 1000, then we will increase the value, plus equals 1. And then press the value, and then we're going to clear all those button down states just to keep things clean again. So hopefully I think that's about it, except obviously we don't have this button repeat routine yet. So let's write that. I think that's probably the most interesting part of this discussion you're going to see. So we'll stick it in this button pressing section of my code. We have those button is down detection and button is up detection functions that are there. And so we'll add this new function. Alright, there is the basic structure. So button repeat, boolean button was down. We'll get the unsigned long, which is the last repeat was done, and the repeat count, okay? Now, if you remember earlier, I discussed that these two values here are being passed as a reference. And to be received as a reference, we also have to identify that. And after looking it up, I found out we have to do this little asterisk. And when dealing with these, we have to deal with them as asterisks, whatever. So this asterisk indicates that we have received this not as a new value or as a value that we've defined here and then filled it with the value from the caller. This is saying that we have received the address of this value and we will work with that address. So we won't create a new variable, we'll work with that address and we'll manipulate that address. So that allows us to manipulate those variables declared in that submenu remotely here. So the first thing I'm going to do on coming in here is I'm going to take a snapshot of the current time because we're going to use time a couple of times, and so I'll just take a snapshot of it once so we know when we came in. The next thing we want to know is if the button was down, because if the button's not down, then we don't need to do anything, right? So let's set it up. So it would be if button was down, then we're going to do something. If it's not down, then we know that the value will be false. So in any case the button is actually not down when it comes into this routine, it's not going to trigger any action basically, right? So here we have it, button was down. So that's great, the button is down. But we need to consider more aspects to actually do an effective repeat. So what are the situations that we're going to do in this repeat? Well, in my repeat I do 3 types of considerations. The first one is going to be if this is the first repeat. If it's the first repeat, then it's going to happen, right? We're going to make it happen. It will be true. It will do the repeat. And then what I will do is I'll take 5 more repeats, around about 5 repeats, I can't remember if it's 5 or 6, but around about 5 repeats, and slowly accelerate the speed of the repeat. And then after the 5th or 6th repeat, we will keep a constant rate of repeat. So there are 3 different cases that we will need to consider. So we have to add this into here, and so the first case will be if that repeat count is 0. So the button was down and the repeat count was 0, and here we have the little asterisk there to say that we're dealing with this not as an address or anything like that, but as a remote variable. So if the repeat count is 0 and the button was down, then yes, we want to trigger an action. Otherwise, the other case for when the repeat count is not 0, if the it's going to be a concatenated one, so I need a bracket. If the repeat count is greater than, say, 5, if there's more than 5 repeats, and the current milliseconds is greater than or equal to the last repeat milliseconds plus 200. So what is that actually saying? That's saying that there are two things we're combining here. We are combining this repeat count, has to be greater than 5 before it considers the next part. And it says that the current milliseconds must now be more than 200 milliseconds than the last repeat. That makes sense, right? So after the 5th repeat, the repeat will occur every, say, 200 milliseconds in this situation. So this is that third scenario that I discussed about earlier. And the second scenario I discussed about is that accelerating or that intermediate section before getting to this greater than 5 situation. So the reason I've done this one first, it's greater than 5, is because I want to branch off here earlier if it's greater than 5 and deal with that fixed 200 millisecond pacing. But if it's not 0 and it's less than 5, then the next scenario will be considered. So if the current milliseconds, so it doesn't matter about the repeat count, it's going to be obviously between the 0 and 5 value. So if the current milliseconds is greater than equal to, now this is tricky and I don't remember it all that well, but let's see if I can explain it. So we'll do it's the same sort of thing, right? It's going to look like this, but this value here is being manipulated, right? It's not 200 milliseconds, it's a manipulated value over time. So if the last repeat milliseconds plus a minimum 250 milliseconds, so that's greater than that. And then what we'll do is we will add a further number of 50 milliseconds delays dependent on how many repeat counts we have made. So that's how we actually get that acceleration happening. So plus 50 milliseconds times the number of repeat counts, right? But obviously this will be increasing over time and we want to be decreasing the delay, and we know it's going to be up to 5, so it'll be, this is going to be star 5 minus the number of repeat counts. So on the first repeat count, on repeat count number 1, we will know this is going to be 1, right? So this section here will be 4, and 4 by 50 is going to be 200. So the first repeat will have to be 200 plus 250, or 450 milliseconds is the first delay. And then on the second one, on the second repeat count, this is going to be, the repeat count will be 2, so this will be 3 times 50, 150, and then onto the 250, which will then give us 400, and so on. So it'll go 450 milliseconds, 400 milliseconds, 350 milliseconds, 300, etc., until we get to the 250 milliseconds, and then we'll move back to being greater than 5 repeat counts here, and then we will lock and stay at 200 millisecond repeat counts. So this is important that you try to understand this a little bit, because you can manipulate these values to do an acceleration rate or a delay rate, whatever suits your needs. You could have a longer acceleration or a different acceleration by manipulating the values we're using in here and manipulating the number of repeat counts before you get to that fixed repeat rate. And then you could also manipulate the amount of repeat fixed rate as well. So you can manipulate all of these values if you like. So understanding them is probably worthwhile. So as we can see, assuming that one of these conditions come true along with the button being down, we're going to do whatever's in this section here. And what we want to do is basically just return true, right? So this is the goal, right? Is to get the true value. But we also do need to do a little bit of manipulation here as well. And the manipulation we need to do is obviously this repeat count, which we can remotely access now, and this repeat milliseconds. We need to take note of that information so that the next value can be moved along. So we need to increase the repeat count just like that, and every time it goes around, or as long as the button is pressed, this repeat count will continue to increase. Now actually I modified this a little bit so that it caps the amount of repeat count it can do, because in this scenario really we're only looking up to repeat count up to 5 is only valid. Once repeat count gets greater than 5, it doesn't really matter. We don't really need to increase this value at all. But I understand that some people might manipulate this repeat count limit. So what I want to do is stop manipulating this value at some point. It's really not that important, but there is a scenario where, in theory, if you held it for 3 years, it might roll around and the repeat count could reset and you would re-enter this acceleration phase, which we should, from a programmatic perspective, endeavor to avoid those sort of little loopholes. So the way that I did it here is to add a little if onto this increment of this repeat count. And for as long as the repeat count stays less than 999, I will keep increasing the repeat count just before I return the true value, okay? And then the second thing we need to do is we need to capture this last repeat milliseconds, which is going to be right at this time. And I could just capture the millis as here, but as I've got this current milliseconds here, I'm just going to reuse that to save a little bit of processing time. So that's it, right? We have the condition here to accept an active repeat or an execution of that function that he's calling it. We have the manipulation of the tracking values, and then we're returning the value. And obviously, if any of these conditions are not true, it's going to return false. Let me add these little comments here, just for my sanity. Now, the interesting thing about C is that within these branch conditions here, this is the one conditional statement, you can actually add comments inside those conditional statements, which is bizarre. I don't see that in other languages. Usually you wouldn't want to have comments in the middle of your functional text because it can create confusions, but apparently it works okay. And in this case it's quite useful because I can understand why I've got each of these conditions in a certain way. Anyway, that's it for this piece of the code. In theory, we now have a repeat function here that works. It will return a true value if the action should be executed because the repeat situation is true. And we have the up and down buttons and a post cleanup here as well, which will manipulate that value. So let's do it, see if it actually works. I'm sure I've made some mistakes again because that's the way it goes. Oh, I've dropped out a couple of brackets here, sorry. Last repeat count 250. 1, 2, oops, there we go. I think that's about right. What have I got wrong now? God, I hate C. You'll hear me say it 1,000 times. I've dropped out a bracket here, which means I will have dropped out a bracket here too. It's terrible. Here we go. You can see I'm writing like Visual Basic here because I've managed to write also first one word. And this is the frustrating thing about this idea. It's really quite difficult to see your mistakes when you're writing. You waste a lot of time. I'm actually using something called Platform 1, and I think in the next episode I might bring it out. I mean, it's just the same code, but in a better IDE, which means that we can avoid all of this BS little errors and typos that you have to put up with while I'm doing this. And to be honest, I highly recommend that everyone switches to Platform 1 as opposed to using this dreadfully awful Arduino IDE. Don't get me wrong, I really am grateful for them doing this, but it's still dreadfully awful. Alright, I think we've got it there, finally. Let's see if this thing even works. UI button test. Press up down to change the value, and we have the value 500. If I'll press it once at a time, I'm pressing down and the value is going down. I press up and the value goes up. So that's working. And now if I long press it, we accelerate and boom, we're off to the races. And if I minus, or plus, sorry, same things. Now the interesting thing about these combination pairs is that there's only one tracking for the repeat count. So if you're in a repeat count and you do an alternating between up and down, it allows you to switch the direction and maintain the current repeat delay rate. It's quite interesting. So if I press down and now I press up and then release down, you'll see that it continues at the same speed in the other direction. So this is really quite a nice feature of having to pair those two buttons together so they work up and down. Alright, so good stuff. We have now a working repeat button, and I think it's quite a useful thing, so I hope you guys can make use of that. Next up, let's do something also pretty interesting. We're going to expand on this repeat button thingy that we've just made, and we'll make a long press, and I'll actually make use of this. I'll make a bit of a fudge, I don't mind to call it that. Instead of writing another subroutine, I'll do a little tricky fudge that allows us to check a long press. So what we use for long press is this OK button, or the accept button, and we'll use that both as a quick press, so if you press it quickly it'll do it, and if you long press it'll do something else. Okay, makes sense? So that means we can multi-function a single button as a long press or a single press. So let's make it happen. So as a part of doing this, the first thing we're going to need is another set of repeat variables specifically for the accept button, and I will just add them up the top here. I'm not going to give a great big explanation. We will have the same thing as we had before, but this will be dedicated for the accept button. So we have the accept button repeat count and the accept button last repeat milliseconds to track when the last repeat was made. Now obviously this is not actually going to be a repeat in the sense of a repeat, this is just a fudge. And a quick way to make use of this repeat function as a long press function as well. So don't get too twisted with the whole thing, it doesn't really matter. Whatever works. Let's put a little bit of a divider here. Don't need this stuff goes here anymore. I'll stick it down here, I guess. Put another divider up here just to make it a bit easier to see. And first up we'll just track the press release action. And it looks pretty much the same as this, right? If the button accept was down and the button accept has been released, then do this function. And pairing up for this, we'll look for the long press situation. Now the code looks basically identically the same as the repeat sort of function up here. Looks pretty much the same. But we are looking at the button accept was down, and we're using the button accept last repeat milliseconds and the button accept repeat count, so a separate set of variables. And I'm going to show you how we're going to use that so it's not a repeat, but it's a long press. As I said, it's a bit of a fudge, but it works fine. So let's ignore this up here for a sec. We know how that's sort of going to work, even though we do need to add a little bit of a condition there. So to check for the long press, what we're going to say is that if the button accept repeat count is equal to 2, when the repeat counts get to 1 and then 2, which should be around about 1 second if I remember correctly, then it will be treated as a long press. So we're just waiting for a certain number of repeat counts to go by before we execute. So instead of writing another piece of code to figure out the time differences or whatever, as I said, this is a fudge. I'm just looking for 2 repeat counts, and then I'm going to execute something specific in this section here. And we'll execute it like this bit of code here I've written. So we'll put a little thing on the screen so we know that the OK button has been long pressed. And as a part of that, we'll also just set the value to 250 as a part of doing something, I guess. So the test value is set to 250, and we print that updated value. Very, very straightforward, okay? Nothing tricky here at all. And then we have the short press as well, all right? So when the button was down and then the button is up, that also could be in the situation that this long press has occurred. So we definitely want to avoid that. So what we'll do is we'll put a condition. So if it's not a long press, in other words, it hasn't made it all the way to 2 yet. So if the button repeat count is less than 2, so it hasn't got to 2. If it got to 2, it would have done the long press, right? So it wouldn't have. We don't want to do both. It's either a short press or a long press. So if it's less than 2, it's going to be a short press. If the repeat count got up to 2, then it's already executed the long press, and it's only going to do it once in any case. So if it is less than 2, we're going to do that, and the key has been released. We will do the following function. We'll say that you quickly press and release the OK button, which you obviously did. And just to keep consistency, I will reprint that test value, unmodified obviously. So that's it, right? So here we have the quick press, or here we have the release state, and in combination with detecting the quick press, and here we have detection of the long press, okay? So if it's long press, if you press it for long enough to get a second repeat count on the second repeat count, it's going to execute that long press action, and then when you release, it's not going to do anything basically. But if you release before it gets to the long press value, then it will act as a quick press basically. And obviously, as this is the release state here, we also need to do a cleanup on this accept was down state. And again, I get quite aggressive with this just to try to clean things up. I will clean all of the buttons up, their down states, and I will reset the accept button's repeat count. So here we just have that blanket clearing of all of the down states, and obviously resetting the repeat count number. I think somewhere along the line I've forgotten to update the entry discussion. We only have the update value. Oh, that's all we had a second ago. So let's add the other descriptive information here. Nice and simple. Quick press to get a message, which is all you get, and long press to set the 250 value. So hopefully that's it, and I haven't messed it up. Sure I have. Let's see if it'll compile, and let's give it a go. Okay, so it seems uploaded okay. Let's give it a go. Okay. And there's all our new menu options. Long press OK to set the value to 250. Let's try that. Yep. And quick press. You get a message, yep. And we can still use these buttons here. They all work fine. And then quick press, yep, doesn't modify the value, and long press. So that's all working fine now. So the next thing I want to do is do this multi-press. So we press the OK up and down button together, we will get some sort of action. Now in the mini lathe, I do sometimes do a combination button action to reset to default, something like that. But I actually have a separate menu item, and I select that menu item, and then that action, that multi-button action is available. And that's like a safety mechanism, so you don't actually accidentally reset your settings if you didn't want to. In this case, we don't have any sort of menu selection, so I do want to sort of minimize this ability to like accidentally press when I was trying to get this multi-action to get these other actions going, you know. So what I'll do is that if the accept button is down, I don't want these other buttons to go, and that will give me a chance to hit the accept button first before the other two buttons and avoid those unwanted actions. So let me do that. Let me just add this to this here, this up-down situation. So as long as the accept button isn't down, I will allow us to do that up-down manipulation of the value. It's pretty clean and pretty straightforward. Now the other thing is that with this multi-press, it's going to be very difficult to check that they've all been pressed down and have all been released all in the same time frame. So it gets quite difficult to sort of check that. It's not impossible, but I don't think it's worth the effort. So what we're actually going to do in this case is just detect when they've all gone down. And effectively, if they've all gone down, this is going to override any of the other functions. So we're going to sort of move it out from this main press, release, and repeat code, and we're going to sort of put it on a higher level in the if chain, effectively. So it will get a first sort of chomp at the cake, we'll say. The code is actually pretty straightforward. We'll just get straight into it. It's going to be right at the header here. I'm just going to copy and paste it because there's really nothing tricky here at all. It just says that if the multi-press wasn't detected yet, and the button accept is down, and the button up is down, and the button down is down, then do something. It's pretty straightforward, right? So this logic state, I haven't got it here. We'd only want it to execute once. So in this action, we're actually going to do the action, and the action will look like this. Again, it's pretty similar to what we did before with the other actions. Multi-press was detected, value we set 750 is what we'll send to the user interface, and then we'll set the test value to 750. I don't know why I have 500 there, but anyway. And we'll print it, okay? But then we need some sort of action management. So once this occurs, once it's detected, we only want to execute this once. We don't want to keep executing it, otherwise it's going to be bad news. So we do have this logic variable, which we need to define off the top, which I haven't done yet. And it just says multi-press detect has been detected true. So once this is true, that will stop it from coming back in here on the multi-press detected, and you'll have your blocking mechanism. So it'll just execute once, I'll wait for all of the buttons to be released, which we need to set up, and then execute it. I know that's all a bit arse about face to discuss it, but I know you're all getting bored of it, so we'll just get to the point, right? So let's add that variable to track that we're using there. Multi-press detect flag, multi-press detected, obviously it's going to begin as false, and then as long as it's false, it will then be able to detect that multi-press, do the action, and then set it to be true. Now we also need to detect the flip side of that, which is to say that if the multi-press was detected, we need to wait for all those buttons to be released, basically. And that's what we'll do with this next bit of code. So the detect case, and here is the release case. If the multi-press was detected, and we detect that all the buttons have now been released, then we can clear that multi-press detect state. Okay, and once the multi-press is in, we're not going to be able to do any of those other functions or buttons until it's released. There might be some leftover up or down states from those buttons, or some leftover repeat states, and so I will just blanket clear all of those states before we get out of this multi-press state. So the was down button all get cleared to not being down, and the repeat counts are all reset to 0. And finally, as this is the master, or the parent routine, or the primary if, we need an if section that allows us to go off and do the normal section of. So that means that we have 3 conditions or states in this main if. The first one is to execute a detected multi-press being held down and entering the multi-pressed mode. The second one is detecting the multi-press mode being exited. And the third one is the normal mode, or that multi-press is not detected and hasn't been currently pressed. And that will allow us to use these normal buttons, or the routines that we've been using up until this point. As long as the multi-press detected hasn't been set true, and we've gotten this far in this if chain, then we will just do the normal button checking routines. And it goes all the way down to here, so we'll just tabulate it once in and add, hopefully, the out bracket. Let's see if it is the right out bracket. Come on. Yeah, it is. There it is here. We'll also add something to our little thing here to tell us what we can do. Press OK, up, down button together. Just set the value to 750, okay? So, what do you reckon, guys? Do you get it? Multi-press, detect, release, and normal button state. Oh, it seems to have compiled without a problem, so that's good. Let's see if this thing works. Test buttons. We've got the new option there. So I'm going to purposely press from the OK across to the others, and if I do it quickly, I should not get any adverse effects. Look at that, multi-press detected, multi-press detected, multi-press detected. Now if I go left to right, hitting the up button first, we're going to get a change in that value. So you see it switches to 751. So we have an ability to avoid that, but it is limited. But we can get the multi-press to detect. And sometimes we get, if we're unlucky, we'll get that count popping in as well. We've hit the OK first. We'll never get it because we put that little blocker in there. And then all of the rest of the buttons work as normal. Well, there you go. So that's it for this episode. I hope it was of some use to you. And I really do thank you for watching this far. And I hope to catch you in the next episode. So I'll see you then.